Okay, here we go with dividing fractions. We've talked about every other operation, adding, subtracting, multiplying, and now we're going to finish up with dividing. Alright, so because whole numbers and fractions are on equal footing on the number line, we've been able to show both of those. We're going to look to division of whole numbers first. So we want to make sure that we establish the definition of division with whole numbers, and then we're going to apply it to fractions. So the definition of division, we've kind of talked about this, but we didn't really write down a definition, but here it is. Given the whole numbers, a and b, then division of a by b in symbols is the whole number c, so that the equality c times b equals a holds, which means is true. So here's an example. If we have 36 divided by 9, it is by definition the number c, so the value of this is a number c, which makes c times 9 equal 36. Here's another example. If we're using words, we say 72 divided by 24 is the whole number c, which makes c times 24 equal to 72. Alright, so how does that apply to fractions? Well, here's a definition. Division of fractions, given fractions a and b, and obviously b not being 0, then the division of a by b, or the quotient of a by b in symbols, is a over b. And it is a unique fraction c, so that the equality of c times b equals a. Notice the similarities between the division of fractions and the actual definition of division. So what this means is if we have 2/3 divided by 1/4, then what that is going to equal c. Which means if we write it as a multiplication problem, then it's the same thing as saying 1/4 times c, or c times 1/4, is equal to 2/3. Alright, so let's go ahead and take a look at this division of fractions theorem. So I went ahead and put it up here so we can refer to it. Let's say that we're going to let the fraction a be called k over l, and we're going to let the fraction b be called m over n. Well, if that's the case, then k over l is equal to c times m over n. And that is true based on what we did on the previous screen. Well, k over l then is going to equal some number c, and I've left a blank here, so we need to come up with something using the information that we have that when we multiply it by m over n is going to equal k over l. And that is this number right here, k over l times n over m. Notice what has happened here. M over n has been flipped around to be n over m. So basically what we have is k over l divided by m over n is going to equal c. If we set it equals c, then this is taking the place of c, and this is what we have. The reason why we need to do that, if you notice, n over m and m over n, if you look at the cancellation law, the n's cancel and the m's cancel, so what are you left with? K over l. So that's why k over l equals k over l, and that's what we're looking for. K over l divided by m over n is this number right here. Alright, so let's prove this on a number line. We're going to do several examples of this, so you will get to see this several times and practice it. So let's say we have 3/2 divided by 4/5 equals some number called c. Well, remember, turning this into a multiplication problem, this is 3/2 is equal to 4/5 times C, or we can also interchange that with 4/5 of C. Remember, 4/5 of and multiplication are the same thing. And when we do our number line, as we're going to build right here, sometimes thinking of 4/5 of C is a little bit easier to put on a number line. So when we design our number line, C is now our new unit. Since we have one C, that is going to be our unit 1. So I start with 0 to C. Now remember, I need 4/5 of C, so I need to partition this so that I can show that here is 4/5. If this is C, then this would be 4/5 of C. It is part of C. So we have 1, 2, 3, 4, and obviously C would be 5/5. Well, the thing is, 4/5 of C, which is right here, 4/5 of C, is equal to 3/2. So we're going to put 3/2 underneath this to show that these two are equivalent. 4/5 of C is equivalent to 3/2. Now the thing is, we need to find what is C. If this is 3/2, then what is C equal to? And that answer is going to show up right here. So now, if it helps you, let's ignore the top part of the number line and let's worry about the bottom half. So if I'm looking at 3/2 here, what are these partitions? What are these partitions? How many partitions do we have? And if you notice, when you count this, we have 4. There's 1, 2, 3, 4. 3/2, pretend, like I said, ignore the top part. If this is 3/2, I have 4 partitions. 1, 2, 3, 4. So this first partition here is 1/4 of 3/2. And again, you can write that as 1/4 times 3/2, which means the next partition is 2/4 of 3/2. And the next one is 3/4 of 3/2. Now I'm going ahead and skipping this one, but if this would be 4/4. So where C is 5/4 of 3/2. And again, you can write that as 5/4 times 3/2. So here is our answer, 5/4 times 3/2, and that gives us an answer of 15/8. So the answer to our question, 3/2 divided by 4/5, is 15/8. All right, so let's prove that. Let's make sure that this works. So let's start with the original problem. Now remember, C is the same as 5 times 3 over 4 times 2, or 5/4 of 3/2. So let's check and see if we end up getting back to 3/2. If this is our multiplication statement, let's see if what we're doing here is going to get us to 3/2. So we're going to replace the C with 5 over 4 times 3 over 2. And notice what happens. If we put this all together and multiply this all the way across, I get 4 times 5 times 3 and 5 times 4 times 2. Well, using our cancellation law, what can we get rid of? The 4s and the 5s, and what are we left with? 3/2. And that's what we started with, 3/2, and we ended with 3/2. So this proves that C is 15/8. All right, let's take a look at another one. 7/3 divided by 5/4. That means 7/3 is equal to 5/4 times some number C, or 5/4 of C. So as we build our number line, we have 0, and we have C, which is, again, kind of acting like 1. And we need 5/4 of that. So we partition our number line, so we get 1, 2, 3, 4/4, and then we need to show 5/4. What is equal to 5/4? It is our 7/3. So we're going to put that underneath 5/4 to show that it's equivalent. And what we need to find is C. What is C going to be? So again, ignoring the top part of the number line, what is this first partition? out of 7/3? Well, there's 1, 2, 3, 4, 5. So this would be 1/5 of 7/3, which again is the same as 1/5 times, whoops, that should be a 7/3. Okay, 2/5 of 7/3, 3/5. So what does that make this? 4/5. 4/5 of 7/3, which is the same as 4/5 times 7/3. And when you multiply that, you get 28/15. So our answer is 28/15. So proving that again, 7/3 divided by 5/4 is 4/5 times 7/3. So if we prove this, we're going to replace our c with 4/5 times 7/3, and you can see what's going to happen. The 5/4 and the 4/5 cancel out, and you're left with 7/3. Okay, moving on. Let's try another example. You're going to have to watch this video probably several times and go over your notes because this is pretty complicated. All right, 6/7 divided by 1/4 equals c. Again, that 6/7 is equal to 1/4 times c, or 1/4 of c. So see if you can predict what's going to happen before I do it. If we make our number line, then we need 1/4 of c. So partition into 4 places, and we've identified 1/4. Well, if this is 1/4 of c, then 6/7 is the first one here. Well, now we need to get all the way over here to c. And if this is 6/7, then what's the next one? Well, the next partition would be 2 times 6/7. And the next one would be 3 times 6/7. So that means c is 4 times 6/7, which if you write it as a fraction is 4/1 times 6/7. And when we multiply that out, we get 24/7. Okay, so again, proving that, 6/7 divided by 1/4. c is now 4/1 times 6/7. And to prove that we're going to get back to 6/7, we replace the c with 4/1 times 6/7. Notice what happens. 1/4 and 4/1 cancel out, and we're left with 6/7. Okay, next one. Let's do this with whole numbers. What if we have whole numbers that we're dividing by? So in this case, we have 5/3 divided by 2. Well, it means 5/3 is equal to 2 times c. Now I'm going to leave the of off of here. It doesn't matter. It just means that we need 2 c's. Well, then c, if this is c, then this would be 2 times c, meaning that we have to get to 2. So 2 times c is equal to 5/3, which means now we want to know what c is. Well, if 5/3 is split up into 2 groups, then this first group is 1/2. This would be 1/2 times 5/3, and we're done. We don't need to go anywhere because we're already at c. So just multiply and you get 5/6. In our proof again, 5/3 divided by 2, we're not going to replace the c this time. You should know that it equals 1/2 times 5/3. So now again, when you do the work to prove this, 2/1 is the same as, or I'm sorry, cancels out with 1/2, and we're left with 5/3. All right, let's change it around. What if you have a whole number divided by a fraction? That would be 5 is equal to 4/3 times c, or 4/3 of c. So building your number line, 0 to 4/3, meaning that 1, wherever 1's going to be, which is at 3/3, is going to be our c. 4/3 is the same as 5. And remember, we want to get to C. So 5 has been partitioned now into 4. 1, 2, 3, 4 segments. So this would be 1/4 of 5, which is 1/4 times 5. So that means the second partition is 2/4 of 5, which means C is 3/4 of 5, or 3/4 times 5. So if we multiply that, you get 15/4, because remember 5 is just 5/1. So proving that again, the C goes away and is replaced by 3/4 times 5. And to make sure that this works, we're going to replace C again with 3/4 times 5. And you can see what's happening here. These are going to cancel out, and what are we left with? 5. All right, so there are several examples there, but basically I think you started seeing is some inverting. Those numbers that cancel out invert, and this is where the invert and multiply rule comes in. It is a direct result of the definition of division. So here is the rule. When you're given two non-zero fractions, the equality C is equal to m over n times L over k. Here is our inversion. K over L has been inverted to L over k. This implies that if you have a division problem, m over n divided by k over L, all it is m over n times L over k. So now when you do division problems, all you have to do is remember to invert the divisor and make it a multiplication problem. So in numbers, if we have 6/7 divided by 1/4, that is going to equal 6/7 times 4 over 1. Okay, and we proved those on those number lines. So, and that's going to equal 24/7. So I'd like you to try this. Try this using the number lines. Go back and look through all your notes and see if you can do this without looking at the answers first. But then restart the video and see if you got it correct. And if not, don't worry about it. This is going to take some work. All right, try it. And now here are the answers. So again, you want to think of this as 5/3 is equal to 3/2 of C. So when you build your number line, you're building it from 0 to 3/2, and you need to identify C is going to be where 1 is. 5/3 is the same as 3/2, or at the same point as 3/2, because we're comparing them, which means we need to find what C is. So if we look at the bottom, 5/3 is split into 1, 2, 3 equal groups. So the first partition is going to be 1/3 of 5/3. The second one is going to be 2/3 of 5/3, which is 2/3 times 5/3. And our answer is 10/9. And to make sure that this works, 5/3 divided by 3/2 equals C. So we're going to replace the C with our 2/3 times 5/3, and we can cancel that out, and we are back to 5/3. Again, this is complicated. I understand this is going to take more than one watching of the video and more than one reading of your notes, and we will be practicing this in class. All right, we'll see you in class.